Welcome to Unit 1, Exploring One Variable Data for AP Statistics. In this video, we're going to tackle Topic 1.8, Graphical Representations of Summary Statistics. This is Part B of Topic 1.8, where we're going to look at a very special type of graph called a cumulative relative frequency graphs. Some people call them ogives, but our normal technical full name is a cumulative relative frequency graphs. That's what I'm going to call it. So this is basically a really cool graph because it's a graph of percentiles. So this is one final way to display quantitative data. So this cannot be used for categorical data. And what this shows, it shows cumulative relative frequency graphs, right? So relative means it's showing proportions, and cumulative meaning it's showing built up proportions. And I'll explain that when we actually take a look at one. So here we plot a point that corresponds to the percentile for that value. Now remember, it's super important that you remember the definition of a percentile. A percentile is the percentage of data below a particular value. This shows how the data is built up. So here's an example we're going to take a look at. Imagine a random sample of 750 people were selected as they were leaving a grocery store in a suburban town. They were asked how much money they just spent on groceries. So people were coming out and we asked them, hey, how much money did you just spend? The following cumulative relative frequency chart shows on the x-axis the intervals of dollar amounts, and on the y-axis its corresponding percentile for each dollar amount. So here's what one of these graphs looks like. It looks like a line graph and they're all connected. So what's happening here is that we have these bins on the bottom, much like for a histogram, right? So this is the $10 to $20 bin, the $20 to $30 bin. So again, your bins all have to be the same size in width. They're all $10 a piece here. So what this first bin represents is, or actually let's talk about this first point right here. This first point talks about that $10, right? The percentile for $10 is a 0%, which means 0% of people surveyed spent under $10. So let's look at another point here, for example. Let's look at this point right here at $40. At $40, we're looking to be somewhere right around, I don't know, maybe 24%, 0.24, 24%. So again, that's the percentile. So that tells me that 24% of people surveyed spent under $40. And this makes sense, right? Because each dot shows how it builds up. So you're always going to see this increasing movement here. And you should always end at 100% because, your final dot, which for me is at $130, shows that 100% of the people I surveyed spent under $130. Okay, so we're gonna, we accumulate all the way till we hit that 100% mark. So every one of these dots again shows the percentile for that particular dollar amount. Now, what other items can be found in these plots, right? The first thing that we could do is we could identify the median, Q1, Q3, and any other percentile. Because remember, the median is known as the 50th percentile. 50% of data above it, 50% below it. So the percentile is 50%. Q1 is the 25th percentile, and Q3 is the 75th percentile. So when we look at this, if I said, hey, identify what the median is, we would look at the 50% mark, which is right here, 50 percentile, and we would slide over and we would find where it meets, and then we would track down as best as we can, and we'd probably say somewhere around $65. So 50% of people spent $65 or less, or vice versa. We can look at the other side, is that 50% of people spent more. So that's the median. The 25th percentile is going to be somewhere right in between 20 and 30%. So if we slide that over and slide that down, we're looking somewhere just below $40, maybe $39. Again, like a lot of graphs, you have to do a little bit of approximating. The 75th percentile would be right here at the 75th percentile. Track it over and drop it down. And somewhere it looks to be right around $75. So it's 75% of people spent under $75. So just a coincidence there that it's both 75, not always going to happen in your data. But again, make sure you understand what a percentile is. It's the percent of data below that value. So we find the percent on the left, connect it over, and that's the value that has, again, 75% less. All right, so the other thing that we could see in one of these plots is where larger or smaller proportion of data fall in the distribution, and this can be seen based on the slopes of the line segments. So for example, we see a really big slope from $70 to $80. We see a big slope there, right? A big change. Well, that shows that there's a large percentage of data in that bin. So if I said, hey, what proportion of people spent between $70 and $80? Well, you could calculate that. All you got to do is subtract. So $70 appears to be maybe about very roughly the 58th percentile. $80 appears to be just a smidgen above 80, so maybe 81. So we could actually subtract those values, and we could do 0.81 minus 0.58, and we get about 23% of people surveyed spent between $70 and $80. And 23% is, a really big chunk. It's almost a quarter of all of the people. So a higher slope, a larger slope between 2 points is going to show a larger amount of people. So a small slope, for example, between 10 and 20, that looks to be only about 5% of people. Again, we're going from 0 percentile to about the 5th percentile. So again, about 5% of people. So you can actually kind of get a feel for how many people fall into each category. So again, we got about 5% of people falling into that first category. Then it gets a little bit bigger, maybe about 10%, then maybe about another growth of 10 or 8%. And then you can actually see that between 60 and 70, there's a pretty big jump. And then again, between 70 and 80, again, another pretty big jump, showing a larger percentage of people that fall into those bins or those ranges. And then again, as we get more and more expensive, we see it really start to flatten out. So for example, we see between $100 and $110, very, very few people. We're talking maybe 1 to 2% of people fell into that bin. And we actually even noticed a flat line. There's actually a flat line right here between 110 and 120. A flat line like that would actually represent nobody. So there was 0% change. So from 110 to 120, there was no change in the percentile, which means that nobody fell into that bin. So nobody surveyed spent between $110 and $120. Okay, so we get a real nice feel for how many people fall, or excuse me, not necessarily how many people, what proportion of people fall into each range or each interval there. We can also calculate the IQR. Once again, the IQR by definition is Q3 minus Q1. So if we estimate Q3 to be around $75 and we estimated Q1 to be around $39, we could subtract those to get an IQR of about $36. So that's another common question I could ask you. And then, again, you could get a really nice sense of the shape, right? You can get a sense of the shape of the distribution. Now, again, in my mind, I kind of try to make, and again, this is going to be very, very rough, so please be careful here. But, I'm going to try to think, right? 10 to 20 was about only 5% of people, so a very small chunk. 20 to 30 is a little bit more chunk, about 10% of people. And then again, about another 10% of people from 30 to 40. And then 40 to 50. Again, these increments all seem to be about 10% each. I mean, maybe a little bit different, 10, 11%, but not much. And then I actually reach a little bit of a stall here. Between $50 and $60, it's maybe about a 5%. But then I get this real big chunk. From 60 to 70, I get a big chunk of people. And then 70 to 80, I get another big chunk of people. And then it really kind of dies down. I'm doing a very poor job drawing that graph. I should probably spit it out more. But the point I'm trying to make is early on, there's very small values, very small. And then it makes a big jump again between 60 and 70. Another big jump between 70 and 80. And then it kind of dies down real quick there. And I see less and less chunks or proportions of people in those higher intervals. So this graph to me looks maybe a little bit skewed left, but for the most part, it's actually kind of symmetric, where we see these kind of two big proportions of intervals, two big chunks of data in the middle, 60, 70, 80, $90, and then on each side, it's less and less. It's actually somewhat symmetric. So you can kind of get a nice, somewhat a feel for what this shape of the data is going to look like from this, cumulative relative frequency graph. Okay, let me ask you a couple more questions here. Let's get a little more specific here. So what does the dot at 30, 0.16 indicate? So we notice that there is a dot here at 30, and it looks to be, again, I estimate it to be about 0.16. So 30, 0.16. So what does that indicate? Now remember, it's percentile. So the 16% is a percentile. So that means 16% of people spent $30 or less. So that's what that value really tells me. Then in context, I'm saying, hey, 16% of people that I surveyed spent $30 at the grocery store or less. So make sure you understand that. Next question, what proportion of people spent between 70 and 80? Well, we actually already talked about that, remember? All you got to do is subtract. So you just find the value at 70. So 70 we said was about the 58th percentile. 80 was about the 81st percentile, and you subtract and figure out what's in between. And we already said there's about 23% of data in between. So about 23% of people surveyed spent between $70 and $80 at the grocery store. What does the flat horizontal line from 110 to 120 indicate? Again, we actually already talked about that as well. So that tells me that 0% of people spent between $110 and $120 at the grocery store because there was no change in percentile. Let's see here. What percent of people spent over $80? Okay, this is a good question. So let's take a look at $80. $80 is right here at about the 81st percentile. So remember, that's a percentile. That's the percentage of people that were below. So if I want to ask about the above, all I got to do is subtract away, right? So if 81% of people spent below $80, then that tells me that about 19% of people spent more than $80. So that'd be about 19%. So remember, you know, a percentile is the percent below, but if you know it, then you could pretty quickly figure out the percent above. And the final question is actually very similar. It says how many people. Now, this is one that often tricks kids on the AP test because they don't read. So number 4 said what percent of people surveyed spent $80 or over $80, which we already said was 19%. Now number 5 is saying how many people were surveyed spent over $80. So to figure out how many people, you need to know your total. Remember, there was 750 total people. If we go back to the directions, it said 750 total people were surveyed. So now that I know 19% of people spent over $80, all I got to do is take 750 and times it by that 19% to figure out actually how many people that would be. So we get about 142.5. You can't have 0.5 a person, so I'm going to round that up and say approximately 143 people. Okay? So be very, very careful because, you know, the percentiles are below, at or below, but it doesn't mean I can't ask you about being above. All you got to do is think about the other side of it. And be very careful if it says what percent versus how many, because that could really trick a student up if you're not being very careful. So to figure out how many, all you got to do is take the percentage that you found or the proportion and multiply it by the total number. All right, so hopefully you have a pretty good idea. These cumulative relative frequency graphs are very, very useful, and they do give us a nice feel for where the data is at, how the data is spread, which, you know, is a pretty kind of cool feature. So let's see here. If I wanted to actually talk a little bit more about shape, you know, let's imagine one of these cumulative relative frequency graphs that shows a big chunk of people here, huge chunk of people here, another big chunk, and then it slowly dies off. Well, that's going to clearly be skewed right, because if you think about that, there's a big chunk of people early on, pretty big chunk of people here. So the first 3 bins, that first bin here, second bin, third bin, those first 3 bins have big chunks of people, and then as you move to the right, again, less and less and less people. So that's going to be skewed right. Or another example could be if we start off really slow, very small changes in percentile, and then on the far right, big changes. Well, that's going to be skewed to the left because we see very few percentages of people in those earlier bins, and then to the right, we see a lot more. And then again, my graph, I think, is actually, you know, the graph I showed you with the amount of money spent at grocery stores is actually fairly symmetric, where we see, you know, smaller amounts on the left, big chunks of people in the middle, and then again, smaller amounts on the right. But just understand that these graphs are always going to increase because they're accumulating, right? They're showing you the buildup of data as it moves, as we start to kind of understand and look at our data in these bins that are ordered left to right. So when we see a lot of data on the left, that's going to be skewed right. When we see a lot of data on the right, that's going to be skewed left. And when we see a lot of data in the middle, a little bit on each side, hey, that's nice and symmetric. All right, so that's why these cumulative relative frequency graphs really give us a nice feel for what that shape of the distribution looks like, okay? So pretty cool graphs. Note that they cannot tell us the mean. Like, we don't know what the actual data is. Like, I know that about 23% of people spent $70 to $80 at the grocery store, but I have no idea what those prices were. I mean, I can't say that somebody spent $72 because I don't know that for sure. I just know what percentage of people spent between 70 to 80. I don't actually know what those actual values are. So I cannot calculate the mean. But if I know I'm skewed right, well, then again, go back to what we've learned earlier, that means the mean is going to be a little bit more than the median. If I'm nice and symmetric, like I feel this data is, then you know what? The median, which is about the $65 mark, is probably going to be fairly close to what the mean is. So I can't tell you exactly what the mean is from looking at one of these graphs, but I can kind of get a feel for if it's going to be close to the median or to the left or to the right based on skewness. So it's another cool feature of these graphs. Is that you get a real nice feel for your data. Again, that's what we're trying to show you guys, is how can we use graphs, visual representations to understand a distribution of data. So this is just another way that we can do that with quantitative data. All right, guys, that's it. See you in the next video.